Today's lesson, we are looking at a brand new chapter called the number system, and we are looking at numbers called rational numbers. So rational numbers, complete change of where we were looking at functions and equations in the last couple of chapters. Rational numbers. A rational number is a number that can be written as the ratio of two integers in which the denominator is not zero. Well, if you forgot that the ratio is another word for a fraction, then the word denominator should have reminded you that if they say denominator, we must be talking about a fraction. So it says it can be written as the ratio of two integers, whole numbers and their opposites, in which the denominator cannot be zero. Symbolically, we can look at it like this and say a divided by b, where a and b are integers. Think of your number line hanging in your teacher's room. That number line has positives and negatives, but they're whole numbers. There's no fractions or decimals on there. And then b cannot be equal to zero. B cannot be equal to zero. So let's take a look at this graphic here. We can start inside in the green circle. And inside the green circle, we have numbers that are 4, 9, and 10. 4, 9, and 10. These numbers are examples of natural numbers. Those are examples of natural numbers. Natural numbers do not include negatives, and they do not include zero. Moving to the next circle, it includes whole numbers. Whole numbers, you see they added one kind of number, and that number is zero. So when I talk about whole numbers, I talk about not only the number zero, but I talk about all the natural numbers as well. So whole numbers would be 0, 1, 2, 3, 4, 5, and so on. All right? The next circle is the blue circle, and this says integers. Integers are what's hanging on your teacher's wall on that number line. Whole numbers and their opposites. On the left side, they have the negatives, and on the right side, after the zero, they have positives. What's the only thing they added inside this circle are the negatives. They add the negatives. What does that tell you? It tells you that integers include negatives, it includes zero, and it includes positive whole natural numbers. Then the big box on the outside is labeled rational numbers, and that's what this chapter is about, rational numbers. So rational numbers include natural numbers, whole numbers, integers, and everything that's out here in the box. So if we take a look in the box, we can see that we've got a fraction, 1/2. We have a repeating decimal, 0.4, and the 4 is going to repeat. I have a decimal, 0.45, or 45 hundredths. I have a percent, which would be 0.18, or 18 hundredths. And I have a negative fraction, -3/4. Okay, so rational numbers include lots of kinds of numbers. Okay, we can start with natural numbers. We can include whole numbers. We can include integers. We can include fractions. We can include percents. We've got fractions, percents. We can include terminating decimals. Okay? Terminating means that they end, like 0.45 ends. So we can include terminating decimals. And of course, we have repeating decimals like 0.4 repeating. So hopefully you're looking at this and saying, well, geez, we've done all of these. These are still all the numbers that we've worked with. And you're absolutely correct. Natural numbers, whole numbers, integers, fractions, percents, terminating decimals, repeating decimals are all rational numbers. Well, if numbers aren't rational, what do you think they're called? If numbers aren't rational, what's the opposite? They're irrational. Okay, because IR is the prefix that means not. So right now we're talking and focusing on rational numbers, but we will move into irrational shortly. Write each fraction or mixed number as a decimal. This is a proper fraction, 5 over 8, the smaller numbers on the top, the bigger numbers on the bottom. This bar right here is a fraction bar, and it simply means 5 divided by 8. If I'm using a calculator, I press the number 5 first, then I press the division sign, and then I press 8, and then I press equal. But you need to remember that on your state tests, you're not always going to have your calculator available to you. So we need to do 5 divided by 8. 8 doesn't go into 5, so I am going to put a decimal point and add some zeros here. 8 goes into 5, not at all, so put a 0 up there. But 8 does go into 50 6 times. 6 times 8 is 48. I subtract and I have 2. I bring down and I have a 0. 8 goes into 20 2 times, and 2 times 8 is 16. I subtract and I get a 4, and I bring down a 0. 8 goes into 40 5 times. 5 times 8 is 40, and I have a remainder of 0. So there's where my decimal ends. So 5/8 is equivalent to 625 thousandths, or the lazy way, 0.625. Okay? So I have 5/8 equals 0.625, or 625. This is tenths place, hundredths, and thousandths. So 625 thousandths. They didn't ask us to round it, so we leave it just like that. The next one, number 2, says -1 2/3, and we are doing the same thing. We are changing this to decimal form. Well, first of all, what I want to do is I want to change it to an improper fraction. This is a mixed number. I want to change it into an improper fraction so I can divide like I did the last time. Forget about the negative for now, or what I often do is I just bring the negative over and then I do the math. In order to change a mixed number to an improper, I multiply denominator times whole number and then add the numerator and put it all over the same denominator. 3 times 1 and 3 plus 2 is 5. So it's -5/3. But they don't want an improper fraction, they want it as a decimal. So now let's do our work. Again, I like to just carry my negative over. It's not going to change, it's still going to be a negative. So I'm going to say 5 divided by 3. 3 goes into 5 one time. 3 times 1 is 3, and that leaves us with 2, and I bring down my 0. 3 goes into 20 6 times. 6 times 3 is 18, brings me 2 left over, and I bring down the 0. 3 into 20 is 6. 6 times 3 is 18. I bring down the 2, and I should see by now that I've got a pattern repeating here. So my 6 is going to continue repeating because I'm constantly going to have that 2 left over. So write each fraction or mixed number as a decimal. It does not say to round it. So what we are going to do is use bar notation. So 1.6 with a bar over it because the 6 repeats over and over again. 1.6 with a bar over just the 6. The 1 doesn't repeat, so we do not put it over the 1. Don't forget your negative sign. Okay, it is -1.6, repeating. Next one, it says, in a recent season, St. Louis Cardinals first baseman Albert Pujols, I believe is his name, had 175 hits and 530 at-bats. To the nearest thousandth, here's our first direction on rounding. We have not been told that before. So it says he had 175 hits and 350 at-bats. And what they want to know is to the nearest thousandth, they want us to find his batting average. whole number, tenths, hundredths, thousandths. That means we need to go 4 places in order to figure out how to round correctly. All right, this is the 10,000ths place, and we want to go to at least there so we can round correctly to the thousandths place. When I'm entering this on my calculator, the 175 comes first. The numerator comes first. Remember, this fraction bar is a division, so I hit the division sign. Let me erase this because I have the wrong number here. It's not 350, it's 530. So I'm going to divide by 530, and then I'm going to hit my equal sign. So I have 175 divided by 530, and we hit the equal sign. And what I have here is a number that goes on and on and on. 330, 1886. Well, as I said in the problem, I only need to go to the 10,000th place, 4 places over. 1, 2, 3, 4. This one is going to determine how we round that 0. Will the 0 stay a 0, or do we round it up to a 1? Well, in order to round up, the number to the right of it has to be 5 or higher. In order to keep it at 0, we would say 1 to 4. So this is a 1. The 1 does not change the 0. So Albert's batting average would be 0.330. Does the 0 need to be there? Yes, it does. Why does it need to be there? Because it says thousandths place. So it has to be there, or it would be marked incorrect. Then you would only be rounding it to the hundredths place, and that's not what they're asking you to do. The next one, write 0.45 as a fraction. If we read 0.45 correctly, all right, we would be able to do this much easier. But we've become very lazy and complacent in the way that we read decimals, and a lot of us just say 0.45. Well, in order to think about our decimal place value, all right, this is the tenths place, and this is the hundredths place. And we should certainly know that by now, or be able to pull out the drawer of knowledge in our brains to recall that information, because it hasn't been that long ago. All right, so it says hundredths. That means I take the 45, I remove the decimal, and I put that over the denominator of 100. Well, your 5th grade teachers and your 6th grade teachers and your 7th grade teachers told you all the time that you have to reduce a fraction every time. All right, so in looking at this problem, I see that I've got a 5 and a 0 at the end. Well, if I have 2 numbers that end in 5 and 0, I can divide both by 5. Divide by 5, divide by 5. 45 divided by 5 is 9, and 100 divided by 5 is 20. The factors of 9 are 1, 3, and 9. 1 is not going to change it, 9 does not go into 20, and neither does 3. So I cannot reduce any further. My answer right here is 9/20ths. So when they ask me to write 45 hundredths as a fraction, I need to reduce it from the 45 hundredths that I might have written to begin with. Has to be reduced. The next one says write 5/10ths repeating, or 0.5 repeating as a fraction in simplest form. This is going to make things a little bit more difficult for us. All right, but let's see what we can do. This number is in reality 0.55555, right? And I could go on and on repeating. Okay, it's going to go on and on and on. Well, the first thing we want to do is make sure that we know it's not 5/10. You can't tell me that there's one place value, so the denominator is 10 and the numerator is 5, and you reduce it to 1/2. Because you know that if it's 0.5, really, it would be 0.50. And I would certainly rather have 55 cents than 50 cents. So they are not the same. So do not make the mistake of telling us that that is 5/10 or 1/2. The first thing we're going to do is assign a variable here. So we're going to say that n is equal to our decimal, 0.555. Okay, and I could go on and on. It's going to go like that. I need to get rid of our repeating part here. All right, so what I want to look at is the number of repeating digits I have. I only have one digit that repeats itself over and over and over again, and it's the 5. If it's one digit, I'm going to multiply by a power of 10 with that many zeros after it. Okay, so I have one number being repeated, that's 5. So I'm going to multiply both sides by 10. Let me say that again. I have a 5 repeating, that's one number. So I multiply by a power of 10 with one number, 0, 10. So let's see what that gets us. That's going to get us 10n equals, when I multiply a decimal by 10, you should know the trick by now that 1 0 means one place. So that's going to equal 5.555 repeating. Okay, my next step, I'm going to take my n equals line. I'm going to take this right here and subtract it from this. Okay, so I'm going to go back to my black pen so we're in the same color. Minus n equals 0.555 repeating. What I want you to do right now is try to forget what's above now. Okay, forget about what's above there. Let's focus on the problem that we're looking at right now, which is 10n minus 1n. That's 9n. Okay? 5 minus 5, 5 minus 5, 5 minus 5. Do you see how we've gotten rid of our repeating part? All I'm left with is a 5. The opposite of times 9 is divide by 9. Divide by 9. That leaves me with n equals 5 over 9. All right? What I want you to do right now is take your calculator. I'll wait. Take your calculator, get your phone on, whatever you have to do. Take your calculator, and please do 5/9 on your calculator, which is really 5 divided by 9, and see what you have on your calculator. And when I do that, I get 0.555 all the way until the end when it runs out of room. And that's exactly what we're looking for. So what is 0.5 as a repeat? What is 0.5 repeating as a fraction? It is 5/9. I double checked myself with the calculator. Tough question. Next one's going to be even tougher, but it's the last one for the day. So this time we have 2.18. This mixed number, we want to see it as a mixed number fraction form. So what does this look like? It looks like 1/8, 1/8, 1/8, and I could keep on going and going and going. Okay? What you should see, or what you should be thinking about, is how many digits are repeated. Okay? I have a 1/8, 1/8, 1/8. So I have 2 repeated digits. I have 2 repeated digits. So in order to get rid of our repeating part, we want to multiply by a power of 10 that has 2 zeros on it, because there's 2 repeated. So a power of 10 with 2 zeros is just 100. That's what we're going to multiply both sides by. Okay? First thing we're going to say is that n equals our repeating number, 2.18181818. Okay? I want to multiply both sides by 100. 100 is 100n on that side. I can erase a couple of them because they're repeating. It's the same thing. Multiply by 100. And what does that leave us with? We have 100n equals. If I multiply by 100, I have 2 zeros. I move this decimal 2 places over. That gives me 218.181818, and so on. Okay? Now I go back and I subtract that original piece. So I'm going to subtract the 1n equals Whoops, it's not a 0, my fault. It is a 2.181818. 100 minus 1, 99n. These all cancel. Okay, these all cancel. There's nothing left there. 218 minus 2 is 216. The opposite of times 99 is divide 99. Divide 99. That leaves us with n equals 216 over 99, but that's an ugly number. They want it as a mixed number. So I know that 99 goes into 216 twice. So that gives me 198. So I count up 2 to 200 and then add 16 more, which gives me a difference of 18. So that equals 2 and 18 over 99. 18 and 99 both share a common factor. What is it? 18 and 99 both share a common factor. What is it? It is 9. Keep your whole number. 18 divided by 9 is 2, and 99 divided by 9 is 11. So our answer, the repeating number of 2.18181818 is equal to 2 and 2/11. How can I check myself? Well, I can say that 2 and 2/11 is equal to 11 times 2 is 22, plus 2 is 24, divided by 11. Take your calculator, 24 divided by 11, and I don't know about you, but I got 2.18181818, which is what I started with. So that's today's lesson. Recapping, what did we look at? We looked at some definitions of what rational numbers are and what numbers are encompassed in the vocabulary of rational numbers. We changed some decimals to fractions. We changed some fractions to decimals. So this is what you should be able to do by the end of today's lesson.